Gonna defend speed.
Adding weight doesn't make this harder. It's basic physics. I'm a physics professor. The weights are irrelevant here since they are not moving. Hope that helps.
Return your degree. To calculate how long speed was in there for each fill, I first wrote this Python code that labels each frame with its number. For example, for 10 pounds, his feet left the ground at frame 111 and then touched the ground again at frame 149. I then looked at the metadata of his video, which showed it was 59.94 frames per second. This means his 10-pound flip took 38 frames divided by 59.94 FPS, which is 0.63 seconds. I then did this for all his flips, and as you can see, airtime is decreasing as the weight increases. The moment of inertia of speed modeled as a rod is 1/12 times his mass, which is 150 pounds or 68 kilograms times his height of 5'8 or 1.73 meters to the power of 2, which is 17 kilograms meter squared. Since he will be tucking in mid-flip, we'll use a generous 8 kilograms a meter squared. The moment of inertia added because of the dumbbells will be their mass times their distance to the center of mass squared, which is about 38 centimeters. By doing some more simple math, I calculated the total moment of inertia to be 8.6 kilograms a meter squared for the 10 pounds weight and 12.6 for the 70 pounds. That means it's 57% harder to spin because—
What the fuck is he talking about? What is he talking about? Chat, what is he talking about?
because of the added weights, but that's not all. The angular velocity of each backflip is 2 times pi divided by the air time, which is 9.9 radians per second for 10 pounds and 11.4 for 70 pounds. And as we know, angular momentum is this velocity times total inertia, which means the 70 pounds flip required 67% more torque impulse from his legs compared to the 10 pounds flip. Also, the vertical velocity will be the 0.5 times gravity times his air time, which goes from 3.1 meters per second to 2.7. And since net impulse is total mass times the velocity, it ranges from 225 newton seconds to 270. The time it takes for him to push off is from when his face is at peak tension or when his legs start extending to the first jump frame, which is 0.117 seconds. We can divide impulse by this amount, which means the force required by his legs are 19% greater, going from 10 to 70 pounds. And also total airborne mechanical energy is 52% greater.
Bro. Does anybody in the chat understood a word that came out of his mouth? Bro, chat. Now listen, bro. Y'all know I graduated high school. I got my high school diploma. But what is he? No. Actually, what is he saying though? I actually don't know what is happening right now.